see we have two squares, one with the side length b and one with the side length a. Now these two squares represent the two squares in our equation, so this will represent b square and likewise that square will represent a square. And you can see in this equation the both areas are added together on top, so you could just join the two figures to represent the numerator, and to represent the denominator we have this, a rectangle with the side length b and added a unit square that represents the 1, and its width would be a. Now this represents all of our denominator. Now if you consider the essence of dividing, what you really mean is how many of these rectangles, this modified rectangles, can you fit into the bigger one, right? So first of all, to do that, let's cut open a into two equal parts. It doesn't have to be two equal parts, we just have to cut it in enough equal parts so that its width becomes 1. So accordingly its length should be a square, since we have to preserve the area, so the total area will still remain 1 into a square, which is still a square, so nothing is changed overall. If a was 3 for example, then you would cut it open into 3 parts and so on. Now we match this shape onto the bigger square. You can see since the length of this whole rectangle part is b, it matches up, and that unit square matches up with the 1 into a square part, the a square that we split open. Now you should consider that when you mean that something divides something like exactly and the answer is a whole number, then that would imply that this figure fits into the bigger figure exactly. Now to do that, you can see that this side length b should divide the side length a. So b divided by a should be equal to the number of unit squares that are in the bigger b, these ones. So the number of unit square is exactly a square, so b over a should be equal to a square, which implies that b should be a cube. Now this is one family of solutions that satisfy the equation that would always give you a whole number answer. If you plug in any number that satisfies this equation into this equation, then that will definitely give a whole number answer. But now the question says that we have a whole number, but we have to prove that that whole number is a perfect square. So how do we do that? Now if you consider the number of times we fit this into that is just, well, the number of times this unit square sort of appears, right? So that is a square. So you can fit the smaller figure into the bigger figure exactly a square times. So you could say that this equation is equal to a square, given that this equation is satisfied, this condition is satisfied. Now this would be our answer, right? So a square, if you under root a square, that is a. Now a by definition is an integer.